Hi all, Mark Thomas here. Welcome to another AI Safari session. Still can't believe we're in 2023. 2022 seems like a blur to me. Anyway, today's session is about accelerating business value by thinking like a data scientist. So we're going to get into the head of a data scientist by peeling back the layers of how these guys and gals approach solving problems. And who better than the Dean of Big Data himself, Mr. Bill Schmarzo, to help us navigate the data scientist psyche. Welcome, Bill. Happy New Year.
Happy New Year to you, Mark. And examining the data scientist psyche. Wow, this is going to get interesting.
Oh, yeah. it is going to be interesting. At least that's the idea. Well, glad you could join today. I know you keep a busy schedule. So before we do, can you just give us a little bit of background about yourself?
Sure, Mark. So been in the data and analytics space really long time, 40 plus years. Many Forrest Gump moments in my career where I was at the right place at the right time. And I was very fortunate in the late 1980s to be the lead on one of the very first data warehouse projects. When I was working with Procter & Gamble and Walmart, I was at Yahoo as the vice president of advertiser analytics when we were developing this technology called Hadoop, and just kind of bumped around. And at my heart, Mark, I am a teacher. And what I mean by that is I have the great fortune to work with and talk to many brilliant, outstanding customers and people. And I feel like it's an obligation for me to share what I hear, share what I learn, to help everybody sort of raise the sea level here when we talk about data analytics and AI.
That's great for us. Glad we have teachers like you out there, and impressive experience. I think it just reinforces that you're the guy for this discussion.
Well, I hope so.
So just to do a little bit of level setting here, the term data science has been circulating long enough where I think there are many definitions. So for today's discussion, and from your perspective, what is data science?
Great question, Mark. Way to start it off. Good lead in. So here's what data science is. Data science is about identifying those variables and metrics that might be better predictors of performance. Period. That's it. You don't need to buy a 600-page book. That's all it is. It's just trying to identify those variables and metrics that might, the key word there, of course, is the word might be better predictors of performance. That's all we're trying to do in data science. And we've got a lot of different tools and techniques we use, but it really boils down to, I think it's 15 words.
Okay. Well, simple enough. Simple is good. Simple can be elegant, actually. So now that we know what data science is, and in our line of work, we talk to an increasing number of customers spanning all verticals and sizes who've been planning to hire or who have hired a data scientist, thinking that this alone will open up a whole new world of insights and enable execution of their strategy. And really, they expect results quickly in many cases. But data science doesn't happen really in a silo. It's more of a team sport. At least that's the way I see it. You've suggested that teaching business leaders how data science can improve business performance and lead to faster time to value in data science work. But will you explain why this is important from a data scientist perspective? And also, how do you teach somebody to think like a data scientist?
So let's go back to the definition of data science, which is a great way to cue this conversation. Think about how I described it. Identifying variables and metrics that might be better predictors of performance. The people who have the best insights through their natural intuition to understand what those variables and metrics might be are the people at the front lines of the operations. They aren't your data scientists. They're not your data engineers. They're not your ML engineers. And you're certainly not your senior executive, your vice president of blah, blah, blah. If we really want to build AI and ML models that are relevant, meaningful, and will actually get used within the organization, then we need to bring into this process the front lines of the organization, the people who actually have a really good perspective as far as what are the variables and metrics that might be better predictors of performance. And so the key is to help them think about, well, how do I think like a data scientist? What is my role as a frontline employee in the data science process. And so we have to bring them into the process, have a well-defined framework for which they can work within. But the really key word in that description of what is data science is the word might, because we're
Mhm.
going to explore lots of different variables and metrics, and most of them are not going to be better predictors of performance. The vast majority won't be. Data science is a failure-ridden process. We're going to
Mhm.
try, fail, learn, try again. And
Mhm.
so to get the everybody to think like a data scientist, to convert everybody into a citizen of data science, which is different than a citizen data scientist, we need to basically help liberate how they think about where and how they can apply data and analytics, what are the variables and metrics, and how do I, at the end of the day, use the outputs from these models to help make better informed decisions.
Okay. So if I heard you from a data science perspective, they get the benefit of somebody trying to think like them by having access to SMEs, business leaders, business SMEs that
Yes,
can provide them with those business insights that they're not familiar with or work with
bingo.
regularly.
Yeah, the domain experts, people who've been, they've spent the nurses who knew within a blink of an eye what were the most predictive variables for somebody who was likely to die from COVID, for example. Why it took the country 2.5 years to figure that out, I don't know. But it's again, these are the people at the front lines who the natural human intuition just kicks in. They see things, they see patterns, they see relationships, they see trends, and it's just a natural way the human works. And by bringing them into the process, not only do we end up with much better models, because that's the whole feature engineering process really relies on those domain experts, but then we've set them up for understanding how they can use the outcomes from these models to make more informed decisions.
Mhm. That makes sense. You mentioned a framework for teaching somebody to think like a data scientist. Can you kind of walk us through what that is? Overview?
Yeah, so I have a 8-step process. It should really be 9, maybe 10, but the 8-step process that it guides people through this process starts by understanding the problem we're trying to solve, how the organization defines and measures value creation. The second step is to bring in all the different stakeholders, both internal and external, and understand from that business problem we're trying to solve, what are the ideal outcomes they're trying to achieve, and how are they going to measure KPIs, metrics, business effectiveness. The third step is to identify the analytic assets that were around which we're going to build, the entities around which we're going to build analytics, customers, wind turbines, patients, cars, trucks. The fourth step in the process is the money step. And that's where we bring everybody together to go through a process to identify, validate, value, and prioritize the different use cases you've come up with and the decisions that are encompassed in those use cases to help to drive and optimize that business problem or business initiative. Then
Mhm.
you go through a process of building scores, identifying the variables, the features, build the scores, build the recommendations, and then map those recommendations back to the decisions. So you've completed a holistic process that starts with understanding how the organization creates value and then delivering analytics that are geared towards to help the different stakeholders to actually deliver value by making better informed decisions. So it's an 8-step process.
Got it. So you mentioned, I think it may be between steps 4 and 6, a brainstorming session.
Yes,
I
4 in particular. Four is the money step.
That's the money step. Okay. I did check out some of your articles. Very interesting work, by the way. And you mentioned something interesting, and it's called a BY analysis. A BY analysis as an effective approach to capture brainstorming input from business leaders as part of that brainstorming exercise. Can you elaborate a little bit on what that is, what that means?
Yeah. So when you're going through that brainstorming process in step 4 and then into the feature engineering stuff in step 5 and 6 to build the scores, you want to try to understand by virtue of the business entities. Let's say that let's go back to our COVID situation. So when I'm looking at patients and trying to determine which patients are most likely to have a severe reaction or die from COVID, I want to know variables such as, well, I want to know by age, by income level, by body mass index, by pre-existing condition, by, start thinking about all the different buys around which you want to try to uncover and explore in trying to identify those particular variables and metrics that would be better predictors of performance. So the buy analysis is something that really most domain experts and subject matter experts can really get onto pretty quickly. And they come up with we brainstorm, 100, 120 different buy variables they want to explore. Now we got a process where the data science team says, okay, now what I'm going to do is I'm going to actually go through a process, try to figure out which of those variables are better predictors. Is body mass index and obesity a better indicator of what your likelihood of die from COVID versus age, for example, which, by the way, body mass index is a much better predictor of your risk than age is. So the buy analysis is a way, think about a room with Post-it notes and too many donuts, and people just with posting all these ideas up all over the place. And here's what's really interesting. When you bring together a very diverse set of people from different parts of the organization, you'll soon be shocked how many people are looking at the same problem from a lot of the same perspectives. You'll find that they're saying, well, yeah, I'm looking at that same thing. I'm looking at this as well. And you start to build this coalition of collaboration across these different parts of the organization, which, by the way, makes it easier when you have somebody who has a diverse perspective, even a conflicting perspective. It allows you to bring in that conflicting perspective to try to figure out, okay, how do we balance out these conflicting sort of perspectives and measures against what you're going to try to optimize?
Interesting. And I think, if I'm not mistaken, buy analysis, that was also rooted in some sort of database approach. Is that
Yeah,
right? Borrowed from
I stole it from my my dimensional modeling days back when I was a data warehouse person, and we used to always build dimensional models using the buy analysis. And that would tell us, what are the dimensions are most interested for us. But it was a very useful way in data warehousing to build out your dimension tables, very robust dimension tables. And the same variables that make up our dimension tables many times are the same variables we're trying to use to predict performance. So it was a very natural transition, at least for me. And my students that I work with also glom onto it pretty quickly. I share, not meaning to go too much detail on this, but I share a really simple exercise. I say, I'm going to do this my first day of class, so hopefully none of my students are listening. What I say is that you've been hired by United Airlines, and you've been asked to forecast how many passengers are likely to fly from Chicago to Paris next month. What are the variables you might want to look at? Right? What are the sort of buy analyses you want to look at to try to figure out and predict what those variables, how many passengers are going to fly?
Right.
And so you let them loose and they think about, well, I want to know what the price is. I want to know the weather conditions. I want to know the economic conditions. So you start this brainstorming process, and the students come up with about 70 to 80 different areas or ideas or these buy variables that they want to look at. It's so interesting to watch this process just explode, because what we do as part of this process, as we're brainstorming, we write these things down on Post-it notes and we call it out as we place it on a flip chart. And what happens by calling these things out, it fuels more creative thinking. And so all of a sudden, one idea becomes 3 ideas, becomes 13 ideas, and it just seems to just explode, which is what we want to do. We want to liberate this ideation process, because if we do that well, then we've given our data science team a big jump start on trying to figure out, okay, what variables are really might be the better predictors of performance.
Yeah, no, it seems like an intuitive process, and interesting that you're able to pull it from another discipline and apply it here. So, I mean, your passion aside, you've obviously got a strong understanding of this methodology, which I think is going to be new to most people, most organizations, most business leaders. Do we at Dell offer workshops to help organizations navigate this new approach of collaborating with data science teams?
Yeah, we've just started offering more of these, and what I love to the conversation with our customer starts by what you've talked about in the sort of the title of this episode: accelerating business value. When we start talking to customers about AI and data management, the conversation doesn't start with data. It starts by understanding how the organization defines how it creates value, and what are the KPIs and metrics against which they measure value creation effectiveness. So we actually have a process, a value engineering workshop we take our customers through to help them figure out, okay, if I'm trying to figure out where and how to use data and analytics, I better first figure out what it is that my organization does, how do we create value, and what are the KPIs and metrics. Now, if I know that, then I know what data is probably most valuable. I've got a good handle on the analytics I'm going to need. I'm a step or two down the road on the ML features. I've gone a long way, but Mark, here's kind of the aha moment. Many organizations haven't done a thorough job of defining the concept of the word value, which is why when I talk to customers, I don't talk about technology. I talk about economics. I talk about what are the economics of data and analytics, which of course is the title of my 4th book, right? And understanding when you think about value creation from an economics perspective, it has 2 different variables than financial variables. First off, it's broader than financial, right? When I look at value creation, I'm going to look at customer satisfaction, employee satisfaction, partner financial feasibility, environmental impact, society impact, ethical impact, right? So my definition of value right off the bat expands dramatically, which is critical. Because we start building our AI models, and in particular, start feeding the AI utility function that drives the AI models, if we haven't thoroughly defined the variables and metrics, and even brought in conflicting variables and metrics, we will have confirmation bias and we will have severe unintended consequences, which is what we're seeing today in some of the AI models that are being used to make hiring and credit and education and housing decisions, right? So the value conversation becomes critical, which, by the way, is step 1 in a thinking like a data scientist process. So we go through that process to make sure we really understand, how do we define value, what are the variables and metrics, and now as an organization, I can really start going down this path, because I've got a much more holistic set of variables and metrics around which I'm going to try to optimize, which by the time when I start building my AI and ML models, I can now build models that I don't have to worry about confirmation bias as much.
Right. Yeah, I think a workshop like this would be fantastic and help save a lot of time, and back to realizing value a lot faster. So that's great that you offer those. Is it you who would lead this, or do you have a team?
So I'm working with the Dell Consulting Organization to flesh this out. Most of them today are led by me, just because I like them and I want to do them. And I learn a ton when I work with customers, which is, I'm in this to learn. So I pretty much run those with the help of the Dell Consulting Group.
And you've got, I think you've worked with a pretty good cross section of verticals and organization sizes as well, correct? But both here and abroad.
I think the only industry, Mark, I've not have done any work in is genomics. And I was going to say legal, but I've been recently engaging with a couple of legal firms to help them understand how they can avoid AI confirmation bias in their models and decisions and such. So, yeah, I've seen a lot of different companies. I've seen a lot of sizes of companies. It's always surprising to me how the smaller size companies have a huge advantage in this space. Now, that doesn't seem logical. You're saying that doesn't make any sense, but because the conversation about value creation is a empowerment conversation, where you are actually trying to empower the organization to become this citizens of data science, it's easier to do in a small organization because you have less political barriers in your way.
Yeah, that makes sense. I think initially, like you said, it's not initially intuitive that would be the case, but it makes sense the way you're explaining it.
Yeah, and the beauty of this process, so what we're going to do is take a use case by use case approach, where we've thoroughly gone through a process to align the organization. We've vetted, we identified, we've prioritized in value. We're going to go use case by use case, and each use case has a positive ROI, and we're going to build out our data and analytics architecture use case by use case. And by doing that use case approach, of course, you got to read my 4th book here, it unleashes the economic value of data, which is a very unique economic asset. Think about this from a very simplistic perspective. Data as an asset never wears out, never deletes, and the same data set can be used across an infinite number of use cases at 0 marginal cost.
Right.
There's unfortunately only 2 handfuls of company out there that really understand that and are playing it to the max. Most companies don't understand that. If you understand the economics of data and how it can be reused an infinite number of times at zero marginal cost, then being able to create data sets that are accessible to everybody in the organization, to link in data silos and to eradicate orphaned analytics becomes the mantra for these organizations.
Yeah, we've definitely got our work cut out for us, especially you being the expert.
Good, I love it.
So let me shift a little bit here. As we close our session, I want to shift to a fun question. So you seem like a well-traveled guy. What is your favorite place to visit, and what's cool about it? And I'll add this if you can. I love foods. I'm kind of a wannabe foodie, but if there is a particularly interesting dish in that place that you love to travel, that'd be interesting to know too.
So clearly, my favorite place to go is Ireland. I go there once a year to teach. I'm a associate professor at the National University of Ireland in Galway. I was just there in November. I did a class at the University College of Cork, UCC. I love going to Ireland, and food is great. The Guinness is better. So I go there, and I really, I'm not a food snob. Give me a good burger and or a good steak, and give me a Guinness with it, and I'm happy as can be. But I love going to Ireland, and I used to have the same experience with Japan as well. Is that when I go over there, I get a chance to teach at the universities. The students are marvelous. They show up in mass. You speak for an hour, and you're there for 2 more hours afterwards as they're asking you questions and are taking selfies with you. And it's
awesome.
just a great experience. These people are hungry. These students are hungry to learn about what the future holds for them. And it's great that I have this unique opportunity to help them to be part of that process.
That's great. That's exciting. That's got to be extremely rewarding on many levels.
It is. It really is. It means it makes all that hard work that I do. It pays off. By the way, Mark, I got to make a comment. I noticed your email, Ai.assist at Dell.com. It's interesting, Ai.assist, because I was thinking about that, and the term hockey assist jumped to mind. Right? You know what a hockey assist, right?
Right.
An assist that leads to an assist, right? That's exactly what AI does. AI doesn't solve problems. AI assists people to help solve problems. AI is like a hockey assist, and the phrase AI assist is a perfect analogy for how people should be thinking about AI in their daily lives.
Wow, that's an unexpected insight. I wasn't planning for that, but I'll say this as usual. I'm a bit smarter after our conversations, and today's no exception. Bill, I know we're close to our time here. I want to thank you for carving out time from your very busy schedule to be here. And I also want to thank all of you for taking time to listen to this session. And please check back for future sessions as we track down another expert to help us explore and understand the AI ecosystem. Thank you very much. Thank you, Bill Schmarzo, the Dean of Data Science, the Dean of Big Data, very much.
Thanks, Mark. I enjoyed it very much.